As if naming ionic and covalence weren't already fun enough, I need to teach you guys about how to name acids. Now, acids are basically ionic compounds, but if you look at the bottom of your screen, you'll notice every single element on your screen is actually a nonmetal, but these are still considered ionics because you have an anion and a cation. And that's just kind of the way it works, although it could be easily um, mistaken for a covalent compound. These are technically ionics. Now, what makes them acids is that when in the presence of water, they're going to ionize, which means to dissociate or to separate, to release an H plus ion, shown right here, an H plus ion, or potentially an H3O plus, which is called hydronium. So it's either going to release an H plus ion, which is basically a proton, or a hydronium ion in the presence of water. Um, Again, they're always going to contain hydrogen. If you notice down here, there's going to be a hydrogen at the front, hydrogen at the front, hydrogen, 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 hydrogen. You get the idea. A hydrogen in the front is always going to be a clue that we're talking about an acid, and therefore the way that we're going to name these acids is going to be a little bit different than what we've done before with other ionics and covalents for that matter. These are held together by a covalent bond, but do produce H plus ions in water. So what I mean by that is the way you want to start naming an acid is basically looking at the non-metal portion right here, the chloride, the sulfate, or sulfite or sulfate, okay? Nitrite or nitrate or sulfide. The non-metal portion, the anion on the negative side, is going to really tell you how to name these, okay? So for example, if the anion, this is number one, if the anion, which is the right side of the compound, ends in "ide," for example, this would end with chloride, right? It's a chloride ion. Then the acid name is going to begin with the prefix hydro. Okay, then the end, instead of being hydrochloride, it becomes hydrochloric acid. So if it's, for example, this would of course be hydrogen chloride using the normal IUPAC rules, but it's actually an acid. And so it'd be hydrochloric acid because this is a chloride ion. So hydrochloric acid. Over here, if we add H2S, S is sulfide. That's not sulfate. Remember, sulfate is something completely different. That's sulfide. Because that's dihydrogen monosulfide, which is one way we could name that, it's actually going to be hydrosulfuric acid, not hydrosulfide, but hydrosulfuric acid. Okay, now that's going to be completely different if we have a different ending. And number two, it says if the anion, which again is the right side, the negative portion, ends in "ite," for example, sulfite, then the way we're going to name this is going to be different. There is no hydro. Okay, there's no hydro. And then we're going to say sulfurous acid. Sulfurous acid. So it's not hydro anything, it's just sulfurous acid. Here we have NO2 minus, which of course would be HNO2. Because it ends in nitrite, again, that's going to be nitrous acid. Nitrous acid. All right, and then again, finally, if we have number three, if it says if it ends in "ate," like sulfate, then it becomes sulfuric acid. Nitrate would become nitric acid, okay? Nitric and nitrous are different, and the difference is the number of oxygens. Same thing, sulfate, sulfuric, and sulfurous is different because the number of oxygens, okay? Again, notice these do not have any oxygens because these are just basic anions. So that's the general rules of how to name the acids. Remember that in the formula chart, you have access to the list of the polyatomic ions, which would be very, very useful to have that pulled up as you're going over any of your practice in class. So what we have here is a table of a whole bunch of different acids, and we're going to attempt to fill in this table based on the information that we know. All right, so the very first one we have I negative. That's iodine. That's called iodide, right? Iodide. So H is a +1, iodide is a -1. So if I do the good old swap and drop or crisscross, then of course that becomes this right here, just HI, and that's called hydroiodic acid. Hydroiodic acid, because anything that ends in "ide," like hydride, becomes hydroiodic acid. The next one we have is H3PO4. PO4, the anion is called phosphate, PO4 with a -3 charge. Again, the -3, there's the 3 right there, right? So PO4 with a -3 charge is called phosphate. Therefore, this is not hydrophosphoric. This is just simply phosphoric acid. It's phosphoric acid, not hydro. Again, you're only going to have for hydro something acid, it's going to be just 2 elements only, okay? If you have a whole bunch of elements like this, then that is not going to be hydro anything. It's just going to be something ic or us acid. All right, the next one we have is C2H3O2 with -1 charge, or also CH3CO negative. Those are the exact same thing. Those are acetate. So if I was to make this into a acid, H is a +1, C2H3O2 is a -1. Again, if I do the crisscross or swap and drop, move those ones down there, they cancel out because of course they're both ones. So I do not require a parenthesis because there's no additional acetates. So this is hydrogen acetate, but acetate ends with an 8, therefore it'd be acetic acid. Acetic acid is vinegar, by the way. So that's vinegar, HC2H3O2. That's vinegar or acetic acid. Number 4, it says HNO3. HNO3, the anion is NO3. NO3 has a -1 charge. Again, the 1 would be right there, but it's not written because, of course, it is assumed. Oh, sorry, -1. All right, so NO3 is called nitrate. NO3 is called nitrate, so this is called nitric acid. Again, no hydro, nothing, just nitric acid. Again, if that was NO2, that'd be called nitrous, but NO3 is nitrate, so it's nitric acid. The next one, SO4 with -2 charge. H is a +1. SO4 has a -2 charge. Again, crisscross or swap and drop, whatever you want to call it. What we're going to end up with is H2SO4. I do not need parentheses around the SO4 because there's no additional number out here. It would just be a +1. So it's H2SO4. Again, this is called sulfate. So this is sulfuric acid. Sulfuric acid. I'm sure you guys have heard of that. It's pretty nasty stuff. My word acid looks really horrible, so let me fix that real quick. Acid. Yeah, sulfuric acid you don't mess around with. All right, the next one is chloric acid. Chloric, because it is ic acid, that means its anion must be chlorate. CO3 with a -2 charge. So just double checking myself. Yes, that's called carbonate because carbonate would become chloric. So again, H with a +1 charge, CO3 with a -2 charge. I'm going to go ahead and cross this down there, that down there. What I end up with is H2CO3 parentheses 1. But again, I don't need to write the 1 because it is assumed. That is chloric acid. Number 7, hydrobromic acid. Hydrobromic, that tells me it's HBr. Because hydrobromic, the anion is just bromine or a bromide ion, Br -1. So that's hydrobromic acid, HBr. Again, hydrogen has a +1, bromine has a -1, cross them, cancel out, HBr. Number 8, H2Cr2O7. Wow. Okay, so again, I know it's going to be no hydro on the answer, but what the heck is Cr2O7? If you check your formula chart, it's called dichromate. Dichromate. So the anion is C2O7, and dichromate has a -2 charge. Again, you can see that right there. There's the -2 charge, moved down behind the hydrogen. So dichromate would become dichromic acid. Dichromic that's an H, sorry. Dichromic acid. So because the anion is dichromate, again, it's not hydrodichromic because again, we have a whole jumbled mess of elements. Therefore, there's no hydro. It's just dichromic acid. Number 9, hydrofluoric acid. Hydroic acid tells me that we are dealing with just a simple fluoride ion. Again, just to do this a little bit slowly, here we have H plus and F minus. Again, you guys could probably already figure out what the formula is. I'm going to cross that down there, cross that down there. Obviously, they're going to cancel out because they're both ones. I don't need to write them. They are assumed. There is hydrofluoric acid, HF. Hydrofluoric acid is HF. Number 10, H2SO3. H2SO3, my anion is going to be SO3. And again, the charge is right there, -2. Oops, -2. So therefore, this, again, if you look at your formula chart, SO3 is called sulfite. Sulfite, that is going to become not sulfuric, but sulfurous acid. Anything that ends with ic, this is, ite, sulfite is going to become sulfurous acid. Sulfurous acid, again, the difference is the SO4 and the SO3. That's the difference between sulfurous and sulfuric. I thought we had one other example like that. We do not. Okay, no problem. Number 11, actually, here it is on Q. No, because that's weird. Number 6 and 11. I just noticed number 6 and 11 are identical. Chloric acid is H2CO3, and then they gave us CO3 with -2 charge. Well, that's odd because H is a +1. Whoa, CO3. Sorry, at the bottom of my screen, my pen messes up sometimes. All right, so that is going to go down there. That is going to go down there. And again, we already know what the answer is because it's the exact same thing as number 6. We have H2CO3. CO3, of course, is called sulfate. So, or excuse me, carbonate. I'm thinking about number 10. Carbonate. So this would be carbonic acid. Oh, wow, I did number 6 wrong. I did chloric acid. Oops. Oh my gosh. I'm sure you guys noticed that because you're just sitting there listening to me and I'm too busy talking while I'm thinking that number 6, no wonder it repeats. It actually didn't. So back to number 11, that's called carbonic. Again, sorry, my pen is messing up. It doesn't recognize very good at the bottom of my screen. This is called carbonic acid. Carbonic. Okay, there we go. Back to number 6 because that one is totally messed up. So chloric acid, I was doing carbonic. Chloric acid, the anion would be chlorate, ClO3 with a -1 charge. Chlorate is ClO3, that's a horribly ugly 3, with a -1 charge. So again, H, always a +1. Chlorate, ClO3 with a -1 charge. Again, if you crisscross them, again, or swap and drop, they cancel out because they're both a 1. They are both assumed. I don't need to write them. So chloric acid is HClO3. All right, guys, I'm sorry about the confusion on number 6. Like I said, when I'm talking and I'm writing and I'm thinking, mistakes do happen. So I do apologize for that, but I hope that makes some sense. This is how to name acids. Again, remember that if you guys will notice, every single time the acids have an H in the front, that is not a coincidence. That is how you can recognize an acid very easily and understand that its naming nomenclature will be a little bit different than a regular ionic compound, okay? All right, guys, thanks again for watching. As always, let me know if you have any questions.